Now, when we start looking at the configuration and the basic architecture, we need to really understand what we need in place depending upon the number of machines that we plan on managing. In this type of configuration, this small scale configuration, we're working with an environment where we're under 3,000 devices, probably closer to 1,000 machines, but again, it's considered a small scale configuration. With that, we have requirements that on the core server, we're running a Windows Server operating system that is 2016 or higher. On the core server, by default, we'll have the admin console. As we install the core server, the admin console is there by default. And then we can also have the database there on the core server as well. And for this smaller configuration, we can use Microsoft SQL Express. Now, in the process of installing the core server, we have several shares that get created. We have the LD main share, which is where all of our administrative tools can be found. We have the LD logon share, which is where all of our client-related resources are found. As well, we have the LD log share and the script share. And then also we might create shares for things like software deployment or patch deployment. So additional shares can also be created or used. Now we also can install the console onto a remote machine, which we're going to refer to that as a remote console. And when we're going in and discovering devices or we're managing devices, we're going to have a certain way that we're going to communicate to those devices. Our main form of communication to a managed device is through what we call the CBA or Common Base Agent. This CBA or Common Base Agent is the root method for our device communication. With that, the core server can either do a non-secure communication just to determine if the machine is on the network, if it's awake and alive, and then also in a secure sense with using the certificates on the core server, we can go in and we can do a more secure communication to our devices, to our managed devices. Now also if we're pulling inventory, if we're doing remote control, we have very specific processes and components that we're using to be able to carry out those functions. And so this is kind of what we'll see, the type of configuration we'll see here with a small scale type of configuration. Now with the hardware requirements, you can see here the hardware requirements that would be needed for that small scale configuration. And again, most servers will meet these requirements here. And we'll need about 16 gigs of RAM to effectively drive this. And of course, we need to be able to communicate on the network to be able to have that communication to our devices. Now it shows here working with different storage arrays. This is not a requirement. This is more just a recommendation. We can work with just a single partition as well, but it's nicer if we can work with more of a storage array to be able to effectively store the components we need to in their own environment. Then we move from there up into a medium scale configuration. Now this type of configuration, it shows here the 5,000 nodes, but this is actually can go up much, is going to be at least over the 3,000 devices. And as soon as we go up over the 3,000 devices, the biggest recommendation is moving the database off into its own environment. So the core server will be one server, the database will be on a separate server or a separate environment. Again, we're still running Windows Server 2016 on the core server, and we're still going to have the admin console there on the core, as well as the remote console on remote machines if we need it, if we feel we need that. Now, in this particular case, we're more than likely going to be using Microsoft SQL. Again, we have support for SQL 2016 or above. And we're going to have our shares that get created by default on the core server. Now with that, we're going to also introduce for software distribution a source server. Best practice to have that separate from the core server so that we can have the proper resources to be able to drive things like where our software is coming from, our software deployment is coming from, or patches that might need to be deployed. The actual physical patches can come off of our source server. So again, the source server is defined as a file server while the core server is defined as an application server. So it's better when we get up into the larger number of machines that we're managing that we have the proper resources in place to manage those. And again, we see here the hardware configuration for that type of a medium scale configuration. Again, very similar to what we're seeing with the small scale, but here now, again, 16 gigs of RAM or higher, and usually higher, to be able to go in and drive that type of configuration. And then we get into a larger scale configuration where we might be managing maybe 20 or 30,000 machines. And again, this requires some additional hardware in the way and different type of configuration in the way that we might set this up and configure it. Again, on the core server, again, the resources increase. On the database, the resources increase to be able to handle this larger number of machines that we could be managing. With that, again, we're going to have the admin console there on the core server. We can have the remote console installed in someone's local machine. And we have our source server that we're going to be working with our software distribution. But we can now also introduce preferred servers. The source server, again, is a required element, while the preferred servers are optional pieces. But these are additional distribution points where we can get software packages, our patch content, OS images, drivers for those images. We can get this different content put into a position where we can then distribute this software or patches in a very efficient way. Now, preferred servers are very helpful when we have a multiple site location an organization that includes multiple site locations, as well as organizations that might reside on a very large campus of buildings. And we've got buildings that are not adjacent to where the core server is, and so we can go in and we can install preferred servers. And these can be used to be able to very effectively get our software or other components deployed. And again, here we see, again, with the large scale configuration, the increase in the components. Again, a lot more RAM on the core server, as well as even more RAM for the database server. The database is always going to take the biggest performance hit, and so again, we're going to recommend the higher configuration there for the database. But again, both the database and the core server have a rather large configuration when we really looked at managing these larger number of machines. Now, as I mentioned, we might have devices that might be external to our normal environment. And again, our cloud service appliance is designed to be able to sit in the DMZ, and we can still manage devices. The devices normally would have to connect to a VPN connection to be able to incorporate that type of management capability. With this configuration, we can we can extend these tools out to devices that are outside of our normal network environment and still be able to manage these machines in a very effective way. Now, when we look at upgrade processes, again, we're going to start off with a production environment. Now, with that production environment, when we go to apply an in-place upgrade, where again we can apply that upgrade right over the top of our production environment, we need to be able to test to see if the database is going to be able to be upgraded correctly. Now, to do that, what we're going to do is we're going to take a backup of that database, and we're going to restore that backup over into its own separate environment. And then we're going to go in and install the upgrade there into a brand new environment and take that secondary copy of the database and allow it to go through and upgrade that database. Now, if we do that upgrade and we don't have any issues with the database, then we know we can go back to our production environment and we can apply that same upgrade to our production environment, not cause any additional problems there with the production environment. However, if when we're applying the upgrade in our test environment, if we do experience problems, then we know what those problems are. And we can go back to our production environment and we can clean up those problems. Again, in an attempt to get us down to where we can go in and we can apply this upgrade to our production environment and be able to do it without creating problems to our database structure. We come out with major upgrades every year as well as minor upgrades every year. And the minor upgrades are referred to as service updates. Now again, we can test these service updates. We can make sure that they can be applied correctly, and we can make sure that your software is running as it needs to.